Today we're going to look at oxidation numbers
Oxidation.
and kind of go over how to define or assign oxidation numbers to elements. We said yesterday that an oxidation number is a theoretical value assigned to a number if electrons were fully transferred to that atom, and they are helpful in determining electrons lost or gained in redox reactions. So helpful for determining electrons lost or gained in redox reactions. Okay, so let's do the oxidation number rules. There's a few that you need to know to be aware of. The first one is that the oxidation number of an atom by itself is?
0.
Wow, impressive. You guys must be doing some studying. Oxidation numbers of an element by itself is 0. So, as an example, if you have Na, you would have an oxidation number of 0. This also applies to diatomics. So, if you have Cl2, you will have an oxidation number of 0 as well. Thank you. Number 2. The oxidation number of an ion is equal to its charge. So the ox number for, and we're going to call it a monatomic ion, is equal to its charge. So if you have, for example, a charge of an ion of Mg plus 2, its oxidation number is simply 2.
Yeah, because don't you have negatives too?
Yep, but if you write 2, it always stands for positive.
Oh!
The oxidation number of hydrogen is equal to
1
plus 1. The oxidation number of oxygen is equal to plus 2. Now there is an exception. Does anyone remember what the exception would be? When you have a molecule that contains what's called a peroxide, which is an O2 found within a molecule, Each of the hydrogens are plus 1, but in this case, the oxidation number of each oxygen is negative 1. I misspoke here. Oxidation number of oxygen is negative 2, not positive 2. In a peroxide is the exception, and it is negative 1. Oh, thanks. Halogens are going to have a negative 1 oxidation number. Okay, so negative 1 for halogens. We have 2 more. Number 6, the sum of the oxidation numbers in all compounds equals 0. Very good. So the sum of the oxidation number of elements in a compound adds 0. And the last one, the sum of the oxidation numbers of atom or of ions within or of atoms within an ion, a polyatomic ion, add to what?
Can you repeat that, Sophia? So jump in.
The sum of the oxidation numbers of atoms in a polyatomic ion add to Cassie?
I have a question. Why did your writing style change throughout the entire thing? Like you were putting in parentheses and now you're circling.
To really bother people with OCD, I try to mix things up a little bit. They add to the charge. Okay. Now, these probably make no sense until we do some examples. So that's where we're heading. We need to do some examples. So let's start here with SO2.
SO2.
The key to doing oxidation numbers is to define the difference between the single oxidation number and the total charge that comes from the oxidation numbers added up. Okay? So start with ones that you always know. Oxygen we know is what?
-2.
So -2 we put right underneath it. That represents the oxidation number of each oxygen. How many oxygens are there? So the total charge coming from the oxidation numbers is -4. If they ask for the oxidation number of oxygen, you always put the top number. This is the oxidation number. This is the total charge coming off of the oxidation numbers added up. Now, you have one sulfur, and we know that Rule 6 says the sum of the oxidation numbers for the atoms in a compound must add to 0. So now you have to say, what can you add to the oxidation numbers added up of oxygen, -4, to get 0? And the answer is +4. So the oxidation number of sulfur is +4. Of oxygen, it's -2. Now let's try CO3, -2. We've moved now from a compound to a polyatomic ion. That -2 charge means when we add up all of the oxidation numbers, they have to add to what?
Oh, yeah.
They have to add to -2. Start with the one you know. It is oxygen, -2. What's the total charge?
-6.
Okay, there's one carbon, and whatever that number is, added to -6 must give -2. Faith, what do you think? What should the oxidation number of carbon be? Nope. 6 plus 6 would give you 0, and we want it to add to -2. So it would have to be, nope, because now 8 plus 6, or 8 plus a -6 gives a +2. Go the other way. There you go. This has to be 4, because now 4, that's okay, 4 plus a -6 gives you -2.
What if you did like the carbon first?
You couldn't do the carbon first because the oxidation numbers, hey guys, if you look up on, or just look at your periodic table, if you see in the upper right hand corner, carbon has like 3 oxidation numbers. See that? It can be +4, -4, it can in some cases be 2. So you only have to go off the ones you know with certainty and then figure out the other ones.
So will there ever be ones that only have
One each meaning one oxidation number? Well, if you have something, yeah, like for example, if you have NaCl, you know Na is going to be +1, you know Cl is -1, you could go either way. Okay, H2SO4.
Is anything with H peroxide or
It has to be an O2 to have be a peroxide. Okay, good question.
So this would be considered
This is not a peroxide because it's not O2, it's O4. Okay, we have 2 choices to start with here. We know 2 of these. Which ones? Hydrogen and oxygen. What is the hydrogen? +1. There's 2 of them, so we have a total charge of +2. Go to the oxygen. Each oxygen is Oxidation number -2. What's our total charge? -8. There is one sulfur. What can you add to the sulfur to balance these out to 0? It has to be +6. If they want the oxidation numbers, again, you take the top row, hydrogen +1, sulfur +6, oxygen -2.
Wait, so, okay, so
Just an O2 within another atom, or within a compound, I should say.
Because
What?
-8 plus 2 is -6. You have to add 6 to get to 0.
So you do that.
Okay, let's do another. These, the only way to really get better with these is just do so many of them that they start to make sense. S2O3, try it on your own. Cassie, what is O? What? What's O? -2. What's our total charge? To balance that out, now be careful, you have 2 sulfurs. So each one must be +3. Now, the +3s balance out with the -6 and you're good to go. Lastly, if we hopefully can fit this one in, CO3 -2. Each oxygen.
You did this one.
Oh yeah, we did do that one. Thank you. We're done. Have a good one.
Have a nice break.